Greetings, fellow mathematical explorers, and welcome to the second outing in the video safari of Euclid's Elements. For your own safety from ferocious geometric beasts while out in the bush, please slap like on this video, press subscribe, and of course, ring the bell. Our map for every journey is Euclid's Elements, all 13 books in one volume, published by, let's see if I can get that right, published by Green Lion Press. It is used with permission. For book number 1, proposition number 2, we have a dot, a point, and we have a line segment. And what we want to do is from this point, create an equal line to that line segment. How do we do that? How do we draw a line segment from that lonely initial point that is exactly the same length as that line segment? Or as Heath's translation says, to place at a given point a straight line equal to the given straight line. Do you have your sunscreen, your bug spray, your safari hat? Let's hop onto the Land Cruiser and go! And don't feed the equilateral triangle. Okay, you can see what we have down there. I think it's pointing the right way. Right down there, we have our point A, and we have our line segment BC. And what we want to do is from point A, we want to create an equal line segment from point A that's equal in length to line BC, or line segment BC. What's our first step? Okay, our first step is to go ahead and create an equilateral triangle. And if you say, hey Alan, how do I create an equilateral triangle? Well, look at book 1, proposition 1, and you can see how to do an equilateral triangle, thanks to Euclid 2. What's next? We're going to extend the line segments. We're going to make DB become DF, and we're going to make DA become DE. So we're going to extend both of those. And this is probably not going to surprise you, given what happened in proposition 1, well, book 1, proposition 1. I'm going to draw a circle. This circle is going to have B as the center, and then have BC be the radius. And you can see you end up with circle GBH. Now what? Another circle. This one's going to have D as the center, and DG as the radius. But of course, DG as a radius is the same as DL as a radius. Are we good? Can you see now how you do the line segment? See if I can highlight it for you. We know that because the circle GCH has B as the center, we know that segment BC and segment BG are the same length, because B is the center and those are both the length of the radius. We also know that the circle with D as the center, so you can say GKL, can you see that going around? We know that DG and DL, if you look at it, top radius that's shown, bottom radius that's shown, that DG and DL are the same length. And because ABD is an equilateral triangle, we know that DB and DA are the same length, which means if we go ahead and subtract those, that BG has to be the same length as AL, which of course is the same length as BC. So do you see what we've got there? Quoting Heath's translation again, therefore at the given point A, the straight line AL is placed equal to the given straight line BC, being what was required to do. Well, fellow geometric explorer, congratulations on surviving another outing. Before we wrap up, remember to check out this video's description to find out how you can own your own copy, let's go right side up, your own copy of the Green Lion Press's Euclid's Elements, all 13 books in one volume. A shout out to Indiana University East, where I'm working on my mathematics degree. Their online offerings make it so that I can feed the family and study the subject that I love. Go Red Wolves! Thanks for joining this excursion in a video safari of Euclid's Elements, and come back soon. The best way to make sure that is likely is to slap like on this video, subscribe to the Math.promo channel, and of course, ring the bell for notices when we will climb back on the Land Cruiser for the next trek into the mathematical bush. Please go to the Math.promo website for links to this and all previous outings. It's time to head back to the lodge. See you again soon.